都知道，2020年呢是大厂进一步拥抱 Rust 的一年。那么在2021年会发生什么呢？我们请到了圣经 The Book 的作者 Rust 核心团队的 Steve，为大家聊一聊 Rust 在2021年的计划。大家掌声欢迎。
Hi, everybody. I'm Steve. Thank you so much for having me at RustChinaConf2020. If you're not familiar with my work, you may have seen this book, The Rust Programming Language, and I am one of the co-authors of the book, along with Carol Nichols, my other co-author. And so you may have seen that. I've also been on the Rust core team for 6 years now, and have mostly worked on documentation, among other things. I also run the Rust Twitter account, which is kind of funny. But yeah, so thank you so much for having me. I'm really sad this is a recording and that I can't actually be there with you all this year. But there's stuff going on that's not possible. So maybe in 2021 I'll be able to actually come attend the conference and say hi in person. But for now, this is a recording and this is how it's going to go. So yes, thank you so much for having me. The topic of my talk is Rust in 2021. So we're going to talk a little bit about what's been happening with Rust in the next year and what you can sort of expect to see out of the Rust project and a couple other things related to that. So the way that the Rust project manages its sort of roadmap for the year works like this. So the first thing that we do is we ask the community for suggestions. So we say to everyone, what is it you want to see in Rust next year? Because that's important. We want to make sure that we're doing things that people find useful and not just stuff that we think is useful. And the best way to do that is to get people to tell us. So we ask for their suggestions. And then step 2, we actually create a roadmap. So we take those suggestions, we take the things that we want to do, we figure out, if there's too much work to do, what things are important and what things we want to put off, and kind of make all those decisions. And then we create an RFC out of that roadmap. And so an RFC is short for a request for comments. And it is the way that the Rust project makes major decisions is by producing these documents and then having people accept them. You can kind of think of it as like the way the government works in Rust. So we create the roadmap RFC out of those suggestions, then of our own ideas, and then we give that back to the community and say, hey, does this look like the thing that you wanted? What do you think about the decisions we made? And we talk about it. And then an RFC is a pull request, so we have to merge it. So once it's accepted, we merge that RFC, and then that becomes sort of the plan. And then step 4 is the hard part, is actually do that work and get the work done. So this is kind of the general process by which this is even decided in the first place. How do you decide what you're going to do? With that being said, the way that this starts off is that asking for suggestions. So every year we kind of announce that this is the process, and we talk about asking for that feedback. And so this is the blog post that's titled Planning the 2021 Roadmap. That happened on September 3rd, as you can see. And so we started that process in September. The reason why is it takes some time to do all that work, and we want to try to get it done before the actual year starts. But funny enough, we've actually never quite been able to get it to happen on time. One year, the plan wasn't ready until March, and the next year it was back in February. So we're really hoping that for 2021 we could have it finished by December, so that way we would know what's going on before the year actually starts. And so what we said in that blog post was we're expecting to have the proposal by November, and then the merging of the RFC by mid-December, and that's kind of what we were shooting for. So September we ask for feedback, make the proposal by November, get it done in December. 2021 starts, we're all ready to go. Now, because this is a pre-recorded talk, I am recording this a little bit earlier. You may see it's the December 9th. And when you all see this, it will be at the end of December. So there's a couple weeks. And so that's right around that period. So technically, I'm recording this before the plan said that the plan would be done. So in theory, there's changes. But also, practically speaking, we are running a little late this year. So it turns out that actually we're not quite going to be actually done by the time this happens. And so what I'm giving you here, this plan today, is probably what's going to happen, but technically the decision has not yet been made. So, um, you know, there's still some room for some things to change and for some things to happen. So I'm sorry if I don't get all of these things finished, but I'm going to try to give you examples of the things that we want to do that we know are going to stay the same. But I just want to acknowledge explicitly that like part of suggesting this talk was that it would happen right after the plan was finished, and now the plan's running a little late. So it is what it is. But there's kind of three things that were in this version of the RFC. Three things that were in this version of the RFC that we want to try to accomplish. And I'm imagining this stuff is roughly the same, even if the words aren't exactly like this is sort of the intention of what's going on. So the first one is to prepare for a possible Rust 2021 edition. I'll talk a little bit about what editions mean in the future of this talk. Then follow through on in-progress designs. And finally, improve the project functioning and governance by helping people be able to know what's going on in Rust and increase mentoring and do sort of stuff like that. So this is a lot of words, but it's sort of going to be the structure of this talk. I'm going to give 3 examples of each of these 3 things, and so we're gonna talk about what these things are. Like I said, some of the specifics may change a little bit, but you know, this is sort of the way that we've been thinking about what we want to do for next year. So these are kind of the big points. So yeah, the 3 sections I'm going to talk to you about today are, first of all, Rust 2021, secondly, the Rust Foundation, and third, a feature called Const Generics. If that doesn't mean anything to you, don't worry. We'll get into the specifics, but these are sort of 3 things that are going to happen next year, and I want to share with you the details of how that's going to work. So, first part, Rust 2021. This is the version of the RFC that is up whenever the talk is recorded. However, I can also let you know that we're working on a second version, so it's going to be a little bit different, but the general idea is roughly the same, and that is that we're going to have a Rust 2021 edition. And so what that means is every 3 years, Rust puts out sort of like a new major version of Rust, and we name them after the years. So Rust 1.0 was Rust 2015, and then we had Rust 2018, so now it's 2021, so we're going to do something for Rust 2021, and we're hoping to continue that 3-year schedule into the future. So if you want to read all of the details of all of the specifics about what's happening, this RFC or the follow-up will be the place to do that. But the general decision is that we're going to do this. Now, we hadn't technically decided that we were going to do it every 3 years. We had only had the like 2015 and 2018 editions. But this is kind of like saying, hey, we're definitely going to do it every 3 years. There were some people that argued we should only do it every year, or we should do it every 5 years, or we should do it only whenever we feel like it's needed. But we really wanted to continue, just like how Rust has releases every 6 weeks, we wanted to do editions every 3 years, because we think that's like a long enough period of time for interesting things to happen, but not so fast of a time that you know, it's also a little confusing. So it also helps that the C and C++ standards processes take roughly 3 years at this point. So it's kind of nice that you know, we're similar to the way that works. So yeah, you may be wondering exactly what's in this edition and kind of what it means. As I mentioned, we have 2015, 2018, 2021. And the way this works is it's not like other languages where you kind of have major changes where everything breaks and you have to rewrite all your code. It's more of like a set of refinements. So an example of the changes in Rust 2018, we wanted to introduce Async Await, but async was not a keyword originally, so we needed to make it a keyword. And so normally that would break people's code, but sort of the way that it happens is in Rust 2015, it's not a keyword, but in Rust 2018, it is a keyword. And so you're able to opt in and say, I'm using Rust 2015, and I want to name my variables async because I have a reason for doing that. Whereas in Rust 2018, if you try to name a variable async, it'll be like, hey, async is a keyword, you're not allowed. So this lets people opt into kind of like breaking changes, which is nice because it means your code keeps working. Use the same compiler for everything, and the ecosystem interoperates. So you can use a package that's based on Rust 2015 with your code that's in Rust 2018, and everything all just works together. So that's really, really nice. So the intention is that in the future, like I said, we're going to continue 2024, 2027, and go on after that. So in terms of what will be in Rust 2021, Rust 2015 with the release of 1.0 was obviously a big deal because it was 1.0. It was the first major release. And so that was like a gigantic celebration. And then Rust 2018, it was sort of similar in many ways. There was a lot of really big kind of changes. We redid the module system. Async Await was happening. Non-lexical lifetimes was happening. A lot of like really, really big features that sort of like felt like a big deal. But it's really hard to do really big releases. We like got Rust 2018 shipped in the very last release of the year of 2018. It was supposed to be earlier in the year, but then it kept slipping and slipping because it was so big. And so Rust 2021 is going to be a little different than those previous ones because it's going to mostly have very small changes, not very big changes. And so really, like, it's exciting in the sense that 3 years has passed and, we're continuing to do cool stuff, but it's not going to be as large as those previous releases. So you may or may not even care about the details of what's in Rust 2021, honestly, because it's like a relatively small release. So that's important. And I also think this plays into the maturity of the language too. We just don't have that many big giant things that we want to change about the language anymore. So it's going to tend towards smaller releases with not big and flashy things, as opposed to the really big change that happened in the first couple of years of Rust's life. And that's really cool too. As an example of the kind of small change that I'm talking about, here's some code. So there's a structure, and it's got A and B, which are both I32 numbers. And then in our main function, we create a struct named f, and we create two variables A and B that have mutable references to f of A and f of B. So this is legal Rust code. This works in every version of Rust. It's not a problem. However, I'm going to show you some code next that feels very similar, but it ends up being very different, and that's confusing. So in Rust today, if instead of creating the B variable directly, like we did with A, if we created a closure named Baz, and inside of the body of the closure, we would get a reference to f.b, and then we tried to create the variable B by calling the Baz closure, this feels like the same code. Like all we're doing is adding a closure in the middle. And all that closure is doing the exact same thing that the body of our function has. So this feels like this should work. But it turns out that in Rust today, this code will actually fail to compile. And the reason that this fails to compile is that the closure captures the whole structure instead of just the particular bit of the structure that you care about. So this closure Baz is going to capture all of f, not specifically f.b. And therefore, you're going to get an error that says that A is capturing f, and that Baz is capturing f. So you have two mutable references to the same thing, and so that's not allowed. And you'd be like, well, it's only to A and to B, so it should be allowed. Technically, this is not allowed today. So this code will be like the plan for 2021 is to make this kind of code legal. So instead, closures would capture the specific parts of structures that they need instead of the whole structure. And while that code is maybe technically backwards compatible, it's a little subtle, and it's sort of kind of a change under the hood. And so we would rather make it on an edition where we can be a little bit more. It's a little more okay for things to be changing in a way that's like a little technically breaking. And so this is kind of what I mean by small versus big changes. Like making this code work in the same way that this code works is a much tinier change than, say, all of Async Await. And so I think this is a representative of what Rust 2021 will feel like, is that we'll have the celebration, we'll talk about it, but it's going to have really small detailed changes like this. If you don't understand what's even going on in this code, that's totally fine. My point is that it's very small and very details oriented instead of being like big, giant, new fancy features. So that's what's going to happen in Rust 2021. I'm not going to talk a lot about the other details because we technically haven't decided what's going to be in it yet, like I said. So I don't want to mislead you, but this is an example of the kind of thing we're talking about. It's very small. All right, next, the Rust Foundation. This is the part of the roadmap where we talk about helping the Rust project do its job better and stuff like that. So back in August, there was a situation with Mozilla where Mozilla laid off the people that they were paying to work on Rust. And people kind of got a little sad about this because, those people had jobs and that was important and matters, and Mozilla matters, all these other things. But this matters for Rust because even though Rust is its own project, Mozilla supported the project a lot. And so people got very worried that with Mozilla deciding to not support Rust as much, that there'd be a problem with Rust itself. And so we've been worried about this for a long time because actually Rust has been larger than Mozilla for a while, but there's no really like a good way to talk about that. And so we had talked about setting up an independent Rust foundation that Mozilla would help rather than purely just being like Mozilla helps the Rust project. And so this happened back in August. And so we decided that we were going to go through, and by the end of 2020, we would set up the Rust Foundation, and that would be kind of a thing. It's almost the end of the year, and we've been working on that goal. So earlier in December, we had a Rust Foundation 2021 question and answer series where you could ask questions about the Rust Foundation and kind of give feedback for what that foundation was like. And that's kind of a big giant thing where we were talking with people about our plans. So several people on the core team have been working really hard on getting the Rust Foundation to exist. And so if you're interested in details, you can go read this Rust Foundation Q&A to learn a little bit more about it. That was kind of like the first big thing where we actually announced that we were like what our plans were. So back in August, we said we were going to do this. Now it's December. What have we actually done? So you can read up a little bit about that. There were a lot of questions, 31 at the time I took this screenshot, and I'm sure there will be more asked since then. So there's definitely a bunch of different things, and people asked a lot of really great questions about the details. And the biggest thing is sort of like, what is the point of the foundation in the first place? And so the sentence we came up with to describe it is, the Rust Foundation's purpose is to enable the Rust maintainers to do their best job happily. So we want to support people in their ability to work on Rust and sort of like make that a good experience for people. And so everything comes around that. Another version of this that's really important, and the sort of the first major task of the foundation, is that there's a trademark on the Rust name and logo, and on the cargo name and logo. And so that's owned by Mozilla. And so the intention is that would be transferred to the Rust Foundation so that we can trust that Mozilla won't do anything with the trademark. They've been only fantastic about it so far, but people tend to prefer when a trademark is not controlled by one company, even if it's a company as respected as Mozilla is. So that's kind of one aspect of being able to do this best work, is holding on to intellectual property and dealing with all that kind of other stuff. The other thing that I want to say about the foundation, you notice it talks about helping the people work on Rust. One of the things, and the reason I'm really excited to be participating in this conference, is the Rust project in general knows that there's a lot of people in China who use Rust, and we know that there's kind of like a cultural split where we don't see a lot of people from China getting involved with the Rust project itself. And there's a ton of different reasons about that, of course, but we at the Rust project would really love to have you all be involved and help us do our stuff, because we want to make sure that Rust works well for everyone in China, and that can only be possible if you tell us what stuff you need help with. We don't know, things about you. You do. So we want to make sure that we're doing a good job of serving you and everyone in China. So one of the things I personally am excited about with the foundation is helping people all over the world, including China, make Rust better for what they are. So I can't talk a whole lot about the specifics here, but just you should know that in general in 2021, this is going to be a big theme. And so hopefully we can sort of bridge that gap and get more people, maybe some of you, involved in working on Rust itself, because we think that's really, really important. So again, thanks to the organizers for having me here. I want to make sure to sort of do that outreach because, we know being, a lot of us are from Europe or from the US, we know there's a huge Chinese community. I think I'm in a Telegram room actually, where, I don't know what's going on since I don't speak the language, but it's really important and we care about it. So we would love to try to figure out how to make that work, if possible. Okay, and that is the foundation. Now we're going to talk about Const Generics. So while we have the changes there from the edition, and we have the foundation, which is going to be a really big deal for helping the project get better, what about the language itself? So I picked Const Generics because it is a language feature that is almost going to be stable, and so it's definitely going to be stable in 2021. but it's also a feature that people have been waiting on for a really long time. So I want to talk about this in terms of finishing features in the language and stuff that's exciting that's sort of like coming down the pipeline. Um, this is definitely one of the big ones. So let's talk about it. Um, this is a regular function in Rust. It's called foo. It takes an argument that's an array of integers. So you may have written some code like this or seen code like this. This is Rust that exists today. And so yeah, so arrays are that type with the square brackets and the semicolon, and they have the number of elements and the type of the elements. But there's some tricks with working with arrays, and you may not have seen code like this because honestly, it's a little hard to work with arrays sometimes. And the reason is generics. So if you want to make this array generic, instead of just being an array of I32s, you want to make it an array of any type. For example, you may write a function that looks like this. So you have a function foo that's generic over some type t, and it has an array of t's with 5 of them. So this works totally fine, and this is in Rust, and this is great. But there's a weird thing about it here is this only works for arrays of length 5. What happens if I have an array of length 1 or length 6 or whatever? This doesn't work. So what I really want is to not just be generic over the t, I want to be generic over the 5. And that's where Const Generics comes in. So people had been able to make this sort of kind of work without Const Generics. Specifically, there's this crate called TypeNum that you may have seen before. And as it describes itself, TypeNum is a Rust library for type-level numbers that are evaluated at compile time. So that's kind of what we're talking about here is numbers in the type system, basically. And so TypeNum is a really fantastic library, but it's also a little complicated and hard to use, and it'll make your compilation times go way up because it basically like implements numbers in the type system, which is so cool, but also complicated. So as an example of using TypeNum to calculate things at compile time, here we have a type called x, which is a sum of p3 and p4. And p3 is a number 3 and a number 4, but as a type instead. And so then we can say, please give me x as an integer type, and then convert that to an I32. And so this will actually take the type p3 and the type p4, add them together, spit out an I32 at compile time, and you get 7. Same sort of thing here with type y, an exponent of what is, so I forgot to say the p, sorry. P means positive, so you have positive and negative numbers. So here the exponent, we have -2 to +3. So what is -2 to the 3rd power? Well, if you ask that to be turned into an integer into an I32, you get -8. So this is some very basic math, but you can see there's a lot of ceremony here. We have to say p or n instead of the regular types. We have to create these weird pairs instead of saying like 3 plus 4, just give me 7. Say sum p3, p4, and like all that stuff. So this library is fantastic and it's served the ecosystem well for a long time, but it's more complicated to use and it's slow. So we want to sort of like turn this into a language feature. And so the way this looks like with Const Generics, showed you the code before with the non-generic array and the generic array. Here's the array that's generic over not just its type, but the length of the array. So here we have function foo of t, and then also a const n, which is a u size. So this is how you differentiate the type parameter t is just the name, but a const generic is this const n, and that says this is a value of some kind, and then it happens to be a u size. So we make you say what the type is, since the type is not generic, but the value is what's generic. And so then we have an array of type t and length n. So this will now work for any array, no matter what type and no matter what length. So this is kind of the big motivating feature. I'm focusing on arrays here because it's the thing that's most sort of like needed, honestly, but there's a lot of other cool things that you can do with this. And especially this gets really cool because of embedded systems. So right now, there's a lot of stuff where it's awkward to do this, and so you end up either using a slice or a vector because you need to be able to handle things at any size. But that means that you can't do it for embedded systems or not as easily because you need an allocator and all these other things. And so I'm really excited about this feature to be able to build data structures that don't need an allocator but still know how long they are. And so that's really cool. So that's one thing I'm really excited about. There's also some fancy things around state machines, and there's all sorts of really, really neat tricks that you can do with Const Generics. I don't have time in this talk to get into all of them, so I'm going to show you that the big thing is arrays. Another thing, this has already been fixed in Rust recently, but if you used Rust in the past year, you may have run into some situation where you try to clone an array and it's got 40 things in it, and it's like, I don't know what clone is. And the reason that that's the case is because we couldn't write code like this, we had to implement each type for each trait for every type of every length. And so we only implemented traits for size up to 32. So for example, clone would be working for arrays from 1 to 32, but as soon as you get an array of 33, you're no longer able to clone the array. And the only reason for that is because we didn't have the ability to write this kind of code. So now in the standard library is allowed to use Const Generics, so it's included in there. So you'll already see that working, but you'll be able to write that kind of code for your own code. And so that's a really exciting thing forward. So this is a feature people have wanted for a really long time. There's been a number of different design decisions, and it's finally almost here. It's happening in 2021, so I'm really excited to see this sort of play out. Now, it's also only going to be the very start, so there's definitely more things that we want to do. There's definitely more things that we want to do in the future, but this is kind of like the beginning of this feature, and I'm really excited about it. So another example of how this works in a real thing, not just like a random thing named foo, like what is this useful for? Well, here's an example of using the try_into trait to convert a vector into an array. So we're able to say, this is a vec of U32s, and it has 1, 2, and 3 inside of it. And we want to turn that into an array of 1, 2, and 3. And so here we're able to say v1.try_into. And the reason it's try_into is if the length was 2 or the length was 4, we'd want this to give us an error. But this is able to then, give us the thing successfully whenever the length of the vector is the right length. So this is a small example, but this is already in stable, and you can give it a try today. And there'll be a ton of more things like this in the future. So I'm, like I said, really excited about it. So anyway, that's my summary of some of the things that are going to happen in Rust in 2021. So like I said, we're going to have the Rust 2021 edition. We're going to have the Rust Foundation, and we're going to have Const Generics, and hopefully a bunch of other really exciting features too. So I hope you found my talk informative. And once again, thank you so much for having me. Hopefully next year I can come be there in person. But for now, the video will have to do. And if you have any questions, feel free to email me, and I am happy to try to get back to you to answer anything that you might be curious about. Awesome. Thanks so much.